Arithmetic instructions are of four types: addition, subtraction, increment, and decrement. Now, addition and subtraction act on two numbers. Increment and decrement act on a single number or value. Now, how do we do addition in 8085? Suppose I have a number 05h and another number 04h. Now, while adding two numbers, at least one of the number has to be inside the accumulator. The other number can be in other register, say B. Now, when I use the opcode add space B, what it does is add 0, 5 and 4, that is A plus B, and stores the result in A itself. Now, the add opcode comes in three more flavors, that is ADI, ADC and ACI. Now, ADI does the same job as ADD, but you can give value itself without using the register. It was simple. Now, the ADC opcode does the same work as ADD here, but it also adds the value of the carry, that is maybe 1 or 0, to the result of the sum. That is the answer will be A plus B plus value of carry. Now, ACI works the same way as ADI, that is, but the value of carry is also added in the sum. That is, the result will be A plus 04h plus value of carry. Opcodes for subtraction are analogous to the opcodes for addition. For analogous to add, we have SUB, which does the same job as addition did, but just it subtracts two numbers. That we have one number in accumulator 05, another one in 04. The result 01 is 2 in the accumulator itself. Now, when we want to subtract a value from an accumulator, we can use the analogous SUI opcode, which is same as ADI, but performs subtraction on two numbers. Now, here there is a borrow flag analogous to a carry flag, and when we use the command SBB, what it does is subtract the contents of accumulator with the contents of another register, say B, and minus the content of the borrow flag. Analogous to ACI is the SBI. What does it do? What it does is subtract immediate value from accumulator and minus the value of borrow flag. One thing I forgot to mention was how the the 8085 does the subtraction. It does not use it does not borrow numbers which we usually do while subtracting. It takes the 2's complement of the binary number and then adds the result. The first place of the most significant bit of any number is a reserved for sign. The most significant bit is 1, the number is negative. If the most significant bit is 0, the number is positive. So that is how the microprocessor is able to figure out whether a number is positive or negative. Coming back now, let's go to DAD instruction. So far the instructions we have seen work on 8-bit numbers. DAD works on 16-bit numbers. Using DAD we can add two 16-bit numbers. Now, DAD does not involve the use of accumulator. It's pretty simple to use DAD. This is the opcode for DAD. The operand register pair, which may be BCDE, stack pointer, or actual. So what DAD does is, here I will show it to you here. Your B contains 12H, C contains 13H, H, these are the values which store them. Now, when you use the instruction DAD B, so the numbers in the BC pair are added to the numbers in the actual pair, and the result is stored in the actual. Here is another example for the same, but it involves a carry. Here you can see carry here from here to here. So this is how that works. So far we have seen the instructions which worked on two numbers. The increment instruction just requires one number to work on. Now let's just see one of it. INR B. Now, what it will do is, suppose 08H is the number stored in B, it will increment it by 1 and store the result in B. We have another one which is for a 16-bit number, and it works on a register pair. So INX B will increment the number in BC pair by 1. For example, here BC contains 01H, C contains 02H, INX B will contain 01H, C value will be updated by 103H. So overall the value on BC pair is incremented by 1. Analogous to increment, we have the decrement instruction. It also is in two forms, DCR and DCX. What DCRB does is subtract the value of B by 1 and store the result in B itself. For example, 08H will become 07H after DCRB. One other command that works on 16-bit number is DCXB. What it does is, if BC pair contain, let's say B contains 01H, 02H, so what it does is decrement the content of the register pair by 1. It contains now 01H, and the result is stored in BC pair.